All right, what other things do you guys want to go over? Are you okay with all the gravity stuff?
No, can we rerun that?
Okay, maybe work out, did you guys get 18 right? Or any
I
of...
got 18 right, it was 15 and 17.
All right, let's go over gravity in general and then look at number 17 maybe.
Were we supposed to have the formulas up on the board?
The gravity one was up there, but somehow it got erased, I think, before you took the test.
Yeah.
Because I wrote it before I left that night before. But
Yeah, there's a bunch of formulas up on the board that pertain to the test, and then your student teacher erased all the formulas, so...
Yeah, that messed you guys up. Okay, so gravity in general. Looks like this. Now, Newton is the one who said, hey, maybe everything with mass attracts everything else with mass for some reason that we don't really understand. And that the size of the force depends on two things. How big are the two masses and how far are they apart? And the farthest, the distance apart is more important than the masses, and that's why it's squared in the formula. It affects the force more than the masses do. Or at least more than one mass does. This is always a constant, 6.67 times 10 to the negative 11th newtons, kilograms squared divided by meters squared. That's just a conversion constant, so that when you take kilograms times by kilograms, divide by meters squared, they actually end up as newtons. They shouldn't normally, but this converts the units to the right size of force. They had to experimentally figure that out. It wasn't something that Newton knew off the top of his head. So anyway, let's say that we have something that is, I don't know, 4 times 10 to the 6th kilograms, and something that is 6 times 10 to the 8th kilograms. So these are probably like asteroid-ish size things. And we'll say that they pass close by each other, maybe 1,000 meters in space. What would be the strength of gravity then attracting them to each other? So I am going to plug in the numbers that I know here. At mass 1, I'm going to say is this one, I guess, 4 times 10 to the 6th. Mass 2, 6 times 10 to the 8th. And the radius is 1,000 meters. Remember to square that. So plugging everything in, seeing what we get. Now remember, when you plug in times 10 on most calculators, you can just hit the EE button here, and that means times 10. If you haven't figured that out. Saves you a keystroke or two. And I came up with a whopping 0.16 newtons. Which is, I mean, what? 3% of gravity or something like that? I don't know. So it would be not super strong, but something you could measure as one asteroid is passing by the other. They would start coming together a little bit. A slight amount, yeah, I mean, would change it a little. So the idea here on gravity is, can you crank out the formula, and then can you conceptually figure out what's happening like number 17 is? So 17 on the test is we have two masses, kind of like this, mass 1, mass 2, and distance r. If the force between them to start with is F, and then you make some changes. So changes, you double this one, so this is twice as big, and you double this one, so both, say asteroids, if we're going to use that example, twice as big, and the distance now is, instead of being 1,000 meters, they're 4,000 meters, which is going to put this in as 4 times farther. Okay, having a 2 on the top and then a 2 on the top. 2 times 2 is 4, so that by itself would make the force of gravity 4 times stronger between these two things. But being 4 times farther apart is going to affect it more, because you take the 4 times and you have to square it. So you're going to end up with a 16 on the bottom that you didn't have before. And 4 divided by 16 is obviously 1/4. So the force is going to be 1/4 as big as it was the first time around, which is dF divided by 4 for that one. So it's just kind of a matter of conceptually seeing how the changes affect the answer. What else do you guys have questions on?
When we take the retake, will some of the equations be up on the board? Or are we gonna have
I'll make a sheet this time so it doesn't go away.
It's not like the equations are that hard.
Well, you may not have remembered this constant.
6.67.
Yeah, there was a few of the equations that came up.
Which is a bummer, and I'm sorry that happened, but I, didn't mean for it to happen, but it did. Yeah, Marissa.
Like coefficient of friction. Like
'Kay.
Sometimes it's the kinetic
Mm-hmm.
one, and sometimes it's not. So does that affect how you would use it in the equation?
It doesn't affect how you use it,
Okay.
right? You have friction is always mu times the normal force. So that can be mu static times the normal force, or it could be mu kinetic times the normal force. It's the same math either way. The only difference is mu k is always smaller than static. And the other difference is mu s has a maximum, meaning that it doesn't always have to be giving you its maximum. So if I have a big heavy box that I'm trying to slide, then if I'm pulling on it with a certain pull force, then let's say that friction, static friction, has a maximum value of, 90 newtons. Okay, and so I'm pulling on this thing with 50 newtons to start with, and friction then is pulling back with 50. In other words, it's not pulling with its maximum, because why would it? It's a force that resists what you're doing. Why would it go 90 and you're only 50 and all of a sudden this accelerates the other way? That doesn't really make sense, right? It can only fight against what you're doing. So then you go up to 60, and now it goes up to 60, right? You go up to 70, it pulls a 70, 80, 90, we get to 90, and now you've hit the maximum it can do. And now you go to 91, and it can only hold 90, so now this thing kind of breaks free, you could say. And now it starts accelerating because you have 1 Newton of net force divided by whatever its mass is. Say it's 10 or something. And now there's a little bit of acceleration, now it starts to move. Hello, ladies.
Hello. We were wondering if we could come in tomorrow at lunch and retake the test.
Sure.
Okay. Do we need to turn in the retake?
Yeah, the review online.
Okay. So
Yeah.
we just turn it in tomorrow and we can do it? Okay.
Sure.
Thank you.
Welcome. Anything else? We got a couple minutes. Keenan?
I was wondering if at lunch, can I come in and take the quiz? And
Sure.
The quiz I didn't take, and then I should retake the first test, and then try and come in Friday.
Yeah, that's fine.